Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss today is the continuation of the previous video, composite function. In previous video, we discussed only the basic problems. Now I have taken different types of examples and I am going to show you how to find the composite function. Okay, let us start with the examples. Here is the first example. We are given with f of x and g of x. We are supposed to find f dot g of x. First, let me write the definition. F dot g of x is nothing but f of g of x. First, let me write what is f of x. F of x is x square minus 4x plus 2. So wherever x is there, you have to replace that x by g of x, where g of x is nothing but 3x minus 7. Let me show it on the board. I'm going to fill all the places of x by 3x minus 7. See, all x is being replaced by g of x. The function g of x is nothing but 3x minus 7. So here we can apply a minus b the whole square formula. So after expanding this exponent, we can distribute this and then we will be combining all the like terms. Okay, let us first expand this. If you are using a minus b the whole square formula, you will get a square, that is 3x the whole square is 9x square, plus b square. B square is 7, so 7 square is 49. Negative 2 times ab, so negative 2 times 3x times 7, which is nothing but negative 42x. Can you follow so far? We were just expanding this exponent by applying the formula a minus b the whole square. Now we are going to distribute this. Just multiply negative 4 with every term within the parenthesis. So negative 4 times 3x is negative 12x. Negative 4 times negative 7 is positive 28, because negative times negative is positive. 2 is already there, just bring it down. Now we have a set of terms. We are just going to combine all the like terms. By looking at this expression, we can notice that there is only one x square, so we cannot combine it with any other term. Okay, let this term be 9x square itself. Now let us look for x terms. We have two x terms, am I right? Negative 42x and negative 12x. We are allowed to add or subtract only the like terms. We cannot add or subtract unlike terms. So negative 42 negative 12 is negative 54. Same way, negative 42x negative 12x is negative 54x. And then we have to combine the constants. Constant means a number without any variable. So 49 plus 28 plus 2 is 79. So if you are combining the like terms, we'll get 9x square minus 54x plus 79. That's it for this example. So wherever possible, you can use the identity, the formula, to expand the exponents. That's it for this example. Okay, now let us move on to the next one. Here is the next example. Please notice that we will not be always given f of x and g of x. The function can be different. They can use different variables to denote the function. Here in this example, we have g of x and h of x. Actually, we are asked to find g dot of h of x. I am going to write the definition first. G dot of h of x is nothing but g of h of x. We can proceed the same way as we performed our first example. First, I am going to write the g of x function. G of x is negative 6x plus 5. In this function, I am going to replace this x alone by the h of x. In this problem, did you notice that I have just left the x? I am going to replace it by negative 9x, negative 11. Now let us distribute. This is negative 6x. So g of x is negative 6 times negative 9x. Negative times negative is positive. Same way, negative times negative is positive. So by multiplying, we'll get positive 66. Finally, we have to combine all the like terms. Here we have x terms and constants. There is only one x term, so we cannot combine it with any other term. So let it be as such, and then we are going to combine the constants. 66 plus 5. That's it for this example. So when you're dealing with this problem, you cannot think that it will be given only with f of x and g of x. The terms may vary. And please notice that you have to know what is the rules of signs for addition, subtraction, multiplication and division. Now let us move on to the next example. Now let me take a function with square root. Okay. Please notice that we have a square root function. F of x is square root of 2x minus 5 and g of x is 5x square minus 3. See, in this question we are asked to find g dot f. So we are going to replace this x by the first function. So our job is going to be very easy. In case if you are asked to find f dot g, it will be a bit more trickier because you have to replace x under the radical. So that would be a bit trickier when compared to this one. Okay, let us do this example. First I'm going to write the definition of g dot f of x. I'm going to rewrite this. So this could be rewritten as g of f of x. So what is our g of x? 5x square minus 3. Replace x by f of x, which is nothing but square root of 2x minus 5. Now let us simplify it. We know that square of a square root is nothing but the term itself. I'm going to write the law of exponent here. Square root of a radical. I'm going to take the square. So this is nothing but square root of a times square root of a, which is equal to a. So this is called the law of exponent. Now I'm going to apply the same thing. 2x minus 5, we have square here. So if you take the square, it will be 2x minus 5 times a product in between 2x minus 5. So when you multiply a square root by itself, you'll be getting the expression itself. So it would be 2x minus 5. Can you follow so far? Therefore, this step would become 5 times 2x minus 5 because on squaring, the square root will get rid of. So we will get. Now we can proceed it algebraically. We are just going to distribute this 5 with each and every term within this parenthesis, and then we are going to combine the like terms. So 5 times 2x is 10x, 5 times negative 5 is negative 25. Now let's combine the like terms. We just have only one x term, so we no need to combine anything with this term. But we have two constants with same sign. So whenever you get two numbers with same sign, you're going to add it by keeping the larger number sign in your answer. So negative 25, negative 3 is negative 28. That's it for this problem. So whenever you get terms with square root and all, don't get panic. Please look at the question again and look for what composite function they are asking. So no problem even if you were asked to find f dot of g, because you can just replace it and you can combine everything under the root and give you answer in square root. So it is going to be easier for you. Now let me take one more example. Please read the question. It is very similar to our previous question. In previous example we had square root, but here please notice that you are given a function with cubic root. On the same time, please look at the other equation. We have x cube. So did you notice that there is some relationship between the exponent and this cubic root? Yes, it will be cancelled out. I'll explain you with the law of exponent. So in this question we are given two functions, g of x and h of x. We are asked to find h dot of g of x. First I'm going to rewrite this. This could be rewritten as h of g of x. Am I right? So what is h of x? X cube plus 4. I'm going to replace ex by the function g of x. G of x is nothing but cubic root of x minus 4. Now I'm going to rewrite this cubic root as exponent 1 over 3. Am I right? So whatever number is on the root, you can rewrite the root as 1 raised to that root. So for example, in case if you have nth root of some function or some expression, it is nothing but f of x raised to 1 over n. This is called a law of exponent. You can rewrite the root as exponent in this way. So I'm going to apply the same concept here. So I have applied here. So what can we do here? I hope you're familiar with the power over power rule. In the law of exponents, I'm going to write the rule here. In case if you have power over power like this, when you have a term with exponent and if there is one more exponent there, then you have to just multiply these two. This is called a law of exponent. You can note it down. I'm going to apply the same law here. It means I'm going to multiply these two exponents, 1 over 3 and 3. So if I multiply those two, 1 over 3 times 3 is nothing but 1. Am I right? Any term raised to 1 is nothing but the term itself. So this gets cancelled out. I mean, it will turn into 1. So x minus 4 raised to 1 is nothing but x minus 4. Can you follow so far? So now I'm going to open the parenthesis. Since there is no sign mentioned outside the parenthesis, it is nothing but we are going to multiply it by plus. So plus times the terms is the terms itself. Now you can add the like terms. We just have only one x term and two constants. These two will get cancelled out. So finally you will get x. That's it for this example. So don't worry about the functions given. For your grade, the problems are going to be in this difficulty level only. So it will be easier for you to handle all the problems. All you have to do is just rewrite the given question and start from the outside function. Write outside function ignoring the x alone. After that, you have to replace all the places of x by the other function they are given. I mean the inner one. And then you have to use law of exponent wherever possible. And that will do. Finally, you have to combine all the like terms and give your answer in simplified form. That's it. Hope you're clear with all the examples I have explained in this video. Okay. In case if you have any query, you can let me know. Thanks for watching. See you in the next video.